Have you ever looked at your computer, buzzing away, seemingly doing a million things at once, and felt like it's just this mysterious black box? Like some genius machine running your entire digital life with a mind of its own? Or maybe you've spent those frustrating hours hunting for that one crucial file, only for it to feel like it just vanished into thin air.
Oh, absolutely. We've all been there.
What if mastering this sort of hidden language of your computer's operating system and becoming a digital organization wizard wasn't just about technical skill? What if it was like a powerful secret weapon, something that unlocks unparalleled productivity and robust security, giving you a tangible edge in any career path you choose?
Get ready to level up. This deep dive is your essential guide to understanding the tech that's reshaping every single industry. We're pulling back the curtain on the fundamental forces that govern every computer and mobile device out there, from the complex operations running beneath the surface to the meticulous organization of your digital life. It's all connected.
Okay, before we really jump into the fascinating world beneath your screen, just a quick ask from us. If you're finding these insights valuable, please take just a moment to like, subscribe, and share this deep dive. Those simple actions. They really ensure you won't miss insider tips that could position you for a bright future in your chosen career. And remember, for additional resources that can help you explore these topics further, check out the description below. We've put some good stuff there.
Right. So today we're embarking on a pretty in-depth exploration of operating systems and file management. We're drawing insights from Technology for Success, computer concepts, and other key industry sources. But our mission here isn't just about the theory. It's not just academic knowledge. It's really about empowering you with the foundational skills you'll actually apply, using those essential and emerging business productivity IT tools.
Okay, so practical skills we can use right away.
Exactly. Whether you're studying management information systems, maybe computer information systems, IT, or really any business discipline, at Tarleton State University's Dr. Ciampa College of Business. Understanding these core concepts is paramount. It's fundamental.
It's the base layer for everything else.
It truly is. It's the bedrock for managing everything from, say, word processing and spreadsheets to databases, presentation graphics, even data analytics, and just effective internet use. Our goal today is clear. Equip you with the knowledge to describe IT fundamentals, demonstrate file management mastery, and ultimately excel in this rapidly evolving business landscape.
Okay, let's unpack this then. When I think about my computer, yeah, it's easy to see the screen, the apps I click on. But what's that core invisible engine making it all work? What is an operating system, really, like in simple terms?
Right. Well, think of your computer like that grand orchestra you mentioned earlier.
Yeah.
The operating system, or OS, is the conductor. It's arguably the most important piece of software on your device.
The conductor, okay, I like that.
Yeah, it's really the backbone of modern computing. And it makes sure every instrument that's your hardware plays in harmony. Every note hit at the right time, the whole performance flowing smoothly. The OS acts as that critical intermediary, that bridge between the raw computer hardware, things like your processor, your memory, your storage drives, and all the user applications you actually interact with.
So it's translating between the parts?
Precisely. Its core purpose is to manage these fundamental resources, efficiently. It ensures the CPU isn't totally overwhelmed, memory is allocated properly so apps don't crash into each other, and storage is accessed without, corruption. It allows application developers, the people writing the software, to do their job without needing to know the tiny details of your specific hard drive or graphics card.
Ah, okay, so they don't need a million versions of their app.
Exactly.
Right.
Because the OS handles that complex translation layer. It truly is the platform that makes everything else run. And understanding this is essential for any BCIS 1305 student aiming for efficiency and really just a solid grasp of IT.
So it's not just making things run, it's actively managing the whole show. That's a lot. What are some of the biggest jobs the OS is constantly doing back there in the background that maybe we don't even realize?
Oh, it's doing a ton. Beyond just coordinating, the OS works like a really sophisticated office manager for your entire system. It's constantly performing several primary functions. First, there's resource management. That's handling the CPU, the memory, various devices, making sure everything gets a fair and efficient share.
Okay, resource sharing, got it.
Then, process management is absolutely crucial. It's responsible for creating, scheduling, executing, and eventually terminating all your running programs, or processes, you call them.
Managing all the apps running at once.
Right. And memory management is all about allocating and then taking back memory space for these processes, preventing them from bumping into each other or causing error.
Keeping them in their own lanes.
Exactly. File system management provides that hierarchical structure, folders within folders, for organizing and storing files on your drives. And critically, there's security and protection, safeguarding your data, your privacy, implementing user authentication, access control. Super important.
The security part feels more important than ever.
It absolutely is. And at its heart, the kernel is the central component handling these critical tasks. It operates in a kind of privileged mode with direct access to the hardware. It's essentially the brain of the OS. So just like that office manager keeps everyone productive and the building secure, your OS does the same for your digital environment. And this links directly back to our first learning outcome for BCIS 1305. Describe the fundamentals of information technology concepts: hardware, software, security, and privacy. We're hitting that right here.
Wow. Okay. It sounds incredibly complex now. I can only imagine how basic it must have been in the really early days of computing. How did we get from that to today's sophisticated OSs that can juggle so many tasks all at the same time?
Yeah, you're right. It definitely wasn't always this seamless. The journey of operating systems is a really fascinating historical progression. It's been driven by this constant need for greater efficiency and, maybe just as importantly, more intuitive user interaction. We started way back in the very early days with something called serial processing.
Serial, like one after another.
Exactly. One program at a time, executed sequentially. Imagine a single-lane road with only one car allowed on it at any given moment. No multitasking, no multiple users, just one job finishing before the next one could even start. Very basic.
Slow going, I bet.
Very. Then came batch processing systems, maybe around the 1950s. Here, programs were submitted in batches, often on things like punch cards. Remember those?
Vaguely. From old movies, maybe.
Right. The OS would execute them sequentially, but without requiring direct user intervention for each step. This improved throughput. You could get more work done overall, but it still lacked that interactivity. You'd submit your job, leave, and, hope your results were ready hours later.
Not exactly real-time feedback.
Not at all. The 1960s, though, brought a huge revolution with time-sharing systems. Think early versions of UNIX. This was a massive game changer because it allowed multiple users to interact with a single computer simultaneously.
Okay, now that sounds more like what we have now.
It was the beginning. The OS would rapidly divide the CPU's time into tiny slices among different users and their programs. This created the illusion, and it is an illusion, that each user had their own dedicated computer. It enabled real-time interaction, collaboration, foundational for the multi-user environments we just take for granted today.
So that's how multiple people could use those big mainframe computers.
That's the core idea, yes. Then moving into the 1980s and beyond, distributed systems started to appear. These operating systems could coordinate and manage resources across multiple interconnected computers, treating a whole network of machines almost like a single integrated system.
Like cloud computing, sort of?
Exactly. This was crucial for scalability and performance, and it absolutely laid the groundwork for today's cloud computing and even the way our phones seamlessly interact with networks. This whole evolution just shows this relentless drive for more efficient resource use, better user interaction, and the ability to handle increasingly complex tasks.
Right. Most of us, I think, use Windows or macOS for our daily stuff, our laptops, desktops, but you're saying there's so much more out there powering our digital world, aren't you? And for students, especially, it seems like the choice of OS could really impact your experience, maybe even your grades or group projects.
Absolutely. While Microsoft Windows definitely dominates the desktop world, it's preloaded on the vast majority of PCs, something like over 70% market share globally.
Wow, 70%. That's huge.
It is. And then macOS, which is exclusive to Apple hardware, accounts for maybe under 10% globally, but it's very visible.
Yeah.
macOS is known for its, elegant interface and that seamless integration within Apple's ecosystem. Features like handoff or iCloud Drive working effortlessly with iPhones and iPads.
Yeah, the Apple ecosystem is pretty tight.
It is. But then there's Linux. And Linux isn't just one OS. It's a whole family of open source operating systems. Unlike proprietary software like Windows or macOS, Linux's source code can be modified and distributed by anyone.
Open source, right. Free to use sometimes.
Often free, yes. Distributions like Ubuntu or Fedora are highly customizable and popular with developers. They also power a huge chunk of the internet web servers. Cloud services for giants like Amazon and Google often run on Linux.
Okay, so servers run Linux a lot. And what about our phones?
For mobile devices, the landscape is almost entirely dominated by two players, Apple iOS and Google Android. Both are obviously optimized for touch interaction. And while they all use a graphical user interface, a GUI with Windows icons, menus, and their look and feel, their underlying architectures, they vary significantly.
So, okay, lots of options. Why does our choice of OS matter then? Specifically for business students like those here at Dr. Ciampa College of Business, why can't we just pick whatever looks coolest or, is the cheapest option? Does it really matter?
It really does. Your choice of OS significantly impacts what software you can actually run, how you learn specific tools, and ultimately how effectively you'll work in a professional setting later on. Let me give you some examples.
Please do.
Okay, think about accounting and finance. Many critical applications, like maybe specific versions of Excel with certain add-ins or software like QuickBooks, are often primarily Windows-based.
Yeah.
You might find workarounds, but the main platform is often Windows.
Okay, so finance students might lean towards Windows.
Potentially, or need access to it. Then consider marketing and design. Creative teams often gravitate towards macOS. Why? Partly the integrated ecosystem, partly the availability of specialized graphic design and video editing software that historically ran well or sometimes exclusively on Macs.
Right, the creative stereotype.
There's some truth to it, historically. Now, for management and IT students, you folks need to be OS agnostic, really. Businesses rarely use just one single OS. You'll walk into an office and see Windows machines everywhere, but their web servers might be running Linux and the marketing department might be on Macs.
So you need to be comfortable with all of them.
You need to be able to navigate them, yes. And understand enterprise systems, things like SAP or Oracle, which often run on powerful Windows or Linux servers. Even entrepreneurship. A startup might leverage Linux servers for cost effectiveness, maybe running their website or backend, while using standard Windows machines for office workstations.
Okay, that makes sense. What about just day-to-day student life, group projects?
That's where it gets very practical. Understanding the OS world is vital. When you're collaborating on group projects, and inevitably, your classmates will use different OSs.
Oh, yeah. That happens all the time.
Right. You absolutely need to use universal file formats. Think PDFs, standard .docs files for Word documents. Things that ensure everyone can open and work with the documents without compatibility nightmares.
Good tip. Avoid weird formats.
Definitely. And just understanding your own OS helps immensely with troubleshooting. Knowing how to use Task Manager on Windows or Activity Monitor on macOS to force quit an unresponsive app, that can save you precious time when you're staring down a deadline.
Been there. Force quit is my friend sometimes.
We all know that feeling. And furthermore, knowing how to ensure your OS updates are installed regularly. That's not just about new features. It's crucial for security, protecting your valuable data, your assignments, your personal information. It's a non-negotiable skill for any future professional. This all ties directly back to those course outcomes, like integrating business software applications and creating business documents effectively across different environments.
Okay. After hearing about all that complexity, managing resources, different OS types, it's almost a relief to think about making technology more personal, Can we really tailor our OS, make it work for us, fit our unique workflow and preferences, or are we mostly just stuck with the default settings?
That's a great question, and the answer is absolutely you can. Modern operating systems are actually built with extensive customization and personalization features baked right in.
Oh, good. Like what?
Yeah. Well, the basics. You can change your desktop wallpapers, themes, color schemes to suit your style. More practically, you can pin your most essential apps, maybe your word processor, spreadsheet software, your Tarleton portal right to the taskbar on Windows or the dock on macOS for one-click access.
Ah, pinning apps. Saves hunting for them.
Exactly. Think of your key BCIS 1305 applications right there at your fingertips. You can also set default applications, so, PDFs always open in your preferred reader, or web links always open in your favorite browser.
Okay, where do we find these settings?
On Windows, you'd mostly dive into the Settings app or sometimes the older Control panel. On macOS, it's all centralized in System Preferences, soon to be System Settings. And even Linux, as we mentioned, offers incredible depth and customization, right down to changing the entire desktop environment if you want.
So lots of tweaking is possible. What about in a business setting, though? Do companies let everyone personalize everything?
That's where it gets a bit different. While individual personalization can definitely boost your own productivity, network administrators in businesses often roll out standardized settings across an organization's computers.
So they lock things down.
Sometimes, yes. But it's not just for aesthetics or control. It's usually for very practical reasons, ensuring consistency across the board. which makes IT support much simpler. And, crucially, it enhances security.
How does standardization help security?
By enforcing uniform configurations, they can make sure everyone has the necessary security settings enabled, firewalls configured correctly, and, very importantly, that mandatory OS updates and security patches are applied promptly to all machines. So while you're learning to personalize your own system to be more productive, remember that understanding how and why these settings are managed centrally in a business is also a key skill for a future business leader or IT professional.
Right, understanding both sides.
Exactly. And the practical takeaway here is pretty significant. Just personalizing your OS with things like, say, snapping windows side by side to easily compare documents, or utilizing virtual desktops to keep different projects or courses totally separate and organized.
Virtual desktops. Yeah, I should use those more.
They're incredibly useful. Or even just enabling focus modes to block notifications when you really need to concentrate. These small tweaks can genuinely save you minutes every single day. And those minutes, they add up. Fast. We're talking hours of recouped productivity over a semester, or even more over a career. That's a crucial skill for any business student aiming for maximum efficiency.
Okay, let's go back to the very beginning. When we hit that power button, it still feels a bit like magic bringing our computer to life from, well, nothing. What's actually happening in those first few seconds to get the OS up and running?
It's definitely not magic, but it is a very carefully choreographed dance between the hardware and the initial software. When you hit that power button, a small, specialized program kicks things off. It's called a bootstrap program, or sometimes a bootloader. This little program isn't stored on your main hard drive initially. It's usually stored in your computer's firmware. That's a chip on the motherboard running either BIOS, the older system, or UEFI, the newer, more capable system.
BIOS or UEFI. I think I've seen those terms flash by really fast when my computer starts.
Exactly. That firmware runs first. It performs initial checks, often called a post or power-on self-test, making sure essential hardware components like memory, keyboard are detected and functioning. In modern systems with UEFI, it also does security checks, verifying that the boot software it's about to load is legitimate and hasn't been tampered with by, say, malware.
Okay, so hardware checks and security first.
Right. Once those checks pass, the Bootstrap program's most crucial function is to find and load the main operating system kernel, the core part of the OS, from your storage drive, like your SSD or hard drive, into your computer's main memory, the RAM.
Loading the OS into RAM.
Yes. Once the kernel is in RAM, the OS essentially takes over the reins from the firmware. It starts initializing all its own core functions, loading drivers for other hardware, starting essential system services, and eventually presenting you with your login screen or desktop. That whole sequence ensures the system starts up correctly, reliably, and securely every time.
Okay, so once it's running, my computer can be doing a bunch of things at once. I might have my word processor open, a web browser with 10 tabs, maybe streaming music. That's a lot happening simultaneously. What exactly is a process in that context, and how on earth does the OS juggle all of them without just collapsing?
That's the absolute core of process management, and yeah, it's a truly impressive feat of software engineering. A process isn't just the program code sitting on your hard drive. It's a running program, an active entity that has been loaded into memory and is currently executing or waiting to execute.
So Word running is a process. Chrome running is another process.
Exactly. Each one gets its own dedicated, isolated workspace within the computer's memory and resources. This isolation is incredibly important.
Why is isolation so key?
Because it means one application, say if Chrome crashes, it shouldn't be able to interfere with or crash your Word document, or vice versa. It protects your data and your workflow stability. The OS gives each process a unique identifier, like a passport number, and keeps a detailed record. We call it a process control block, or PCB, tracking its current state, what resources it's using, its priority, and so on.
A passport for every running app.
Okay. Kind of, yeah. And processes move through various states during their life cycle. When you first launch a program, it's in the new state. Then it typically moves to the ready state, meaning it's loaded and waiting for its turn on the CPU. When the OS scheduler decides it's time, it transitions to running. It's actively being executed by the CPU.
Okay, new, ready, running.
Then, if the process needs to wait for something, maybe input from you typing or data to be read from the hard drive, it moves to the waiting state. Once that event happens, like the data arrives, it usually goes back to the ready state, waiting for the CPU again.
Waiting for its turn again.
Right. And finally, when it finishes its task or you close the application, it enters the terminated state, and the OS cleans up its resources.
So how does the OS decide which ready process gets the CPU time next? There might be dozens waiting.
That's process scheduling. And it's critical because remember, a single CPU core can fundamentally only execute one instruction from one process at a precise instant in time.
Only one thing truly at once.
On a single core, yes. So the OS employs different strategies or algorithms to decide who goes next. The simplest is first come, first served, FCFS. Just like a queue or a line, the first process that becomes ready gets the CPU until it's done or needs to wait. Simple, but not always fair or efficient.
Yeah. A long process could block everyone else.
Exactly. That's why a very common method, especially in interactive systems like Windows or macOS, is round-robin scheduling. Here, each ready process gets a small, fixed slice of CPU time, called a time quantum, maybe just a few milliseconds.
A tiny slice of time.
Very tiny. If the process doesn't finish its task within that slice, the OS preempts it, basically kicks it off. The CPU saves its current state and moves it to the back of the ready line. Then it gives the next process in line its time slice.
So it cycles through them really fast.
Incredibly fast. So fast that it creates that illusion of simultaneous execution. It feels like your music is playing while you're typing while your browser is loading, even though the CPU is rapidly switching between them. This is essential for making systems feel responsive.
Ah, the illusion of multitasking. Okay.
There's also priority scheduling. Processes can be assigned different priorities. Critical system tasks might get a very high priority, ensuring they run immediately when needed, while background tasks might have a lower priority.
So the OS prioritizes its own important stuff?
Generally, yes, and applications can also have priorities set. Now, that act of rapidly saving the state of one process and loading the state of another, that's called a context switch. It's the mechanism that enables round-robin and other preemptive scheduling. But context switching itself takes a little bit of CPU time. It's overhead.
It's work for the OS to do the switching.
Right. It's computationally intensive, and if the OS is doing too much context switching, perhaps because you have hundreds of processes demanding attention, the overhead can actually slow the whole system down significantly.
Ah, that's why having way too many apps open makes my computer feel sluggish.
That's a big part of it. The OS is spending more time switching between tasks than actually doing the work within those tasks. Understanding this really shows how the OS orchestrates the core functions, directly supporting that first learning outcome about IT fundamentals.
Okay, that makes sense. Now, our computers often seem to magically run dozens of apps, even really demanding ones like video editors or games, alongside everything else. How does the OS prevent everything from just running out of memory? Or worse, apps conflicting and crashing each other because they're fighting over RAM. It sounds like a really tricky juggling act.
It absolutely is a juggling act, and that's the fine art of memory management. You're right. Physical RAM, the actual memory chips in your computer, is a finite resource. You only have so many gigabytes. So the OS's job here is paramount, making sure each running process gets enough memory to execute properly without letting it accidentally overwrite or corrupt the memory being used by another process.
Keeping them separate is key again.
Absolutely. It's constantly allocating memory when a process starts or needs more, and then deallocating it, freeing it up, when the process finishes or no longer needs it. It sets strict boundaries to prevent one misbehaving app from causing chaos for others. To really get this, we need to think about the memory hierarchy. It's like a pyramid based on speed and size.
A pyramid, okay.
At the very top, closest to the CPU, you have incredibly fast but very small storage locations called registers, right inside the CPU, and caches, small amounts of super fast memory. These hold data the CPU is actively working on right now or is likely to need very soon.
Fastest but smallest.
Right. Below that is your main memory, RAM, the gigabytes you typically think about when you buy a computer. It's slower than cache but much larger. This is where active programs and their data reside.
Okay, RAM is the main workspace.
Yes, and below RAM is secondary memory, typically your hard disk drive, HDD, or more commonly now your solid-state drive, SSD. This is much slower than RAM, but offers vastly more storage capacity. And it's persistent. It keeps data even when the power is off.
Slower but huge.
Yeah.
Got it.
The OS is constantly intelligently shuffling data between these tiers. It tries to keep the most frequently used or most likely needed data in the fastest tiers, cache and RAM, to keep the CPU busy and the system responsive.
Moving data up and down the pyramid.
Exactly. Now here's where the real magic, as you called it, often happens. Virtual memory. Since physical RAM is limited, the OS uses a clever trick. It uses a portion of your secondary storage, your hard drive or SSD, to simulate having much more RAM than is physically installed.
So it uses the hard drive like RAM.
In a way, yes.
Hmm.
It does this by dividing programs and memory into fixed-size blocks, usually called pages, maybe 4 kilobytes each. Then, the OS intelligently swaps these pages of data in and out between the physical RAM and a special swap file or partition on your hard drive, as needed.
Swapping pages back and forth.
Right. If a page of data hasn't been used recently and RAM is getting full, the OS might copy that page out to the hard drive, page out, to make space for a page that is needed right now. This allows you to run more programs or programs that require more memory than your physical RAM alone could handle.
Ah, that's how I can have so much open. But I guess swapping to the hard drive is slower.
Much slower. Accessing the hard drive is orders of magnitude slower than accessing RAM. So if the system has to do too much swapping, often called thrashing, your computer will feel incredibly slow because it's constantly waiting for data to be moved from the slow drive.
Okay, so virtual memory is great, but only up to a point.
Precisely. And to manage all this, each program is given its own virtual address space. It's like each program thinks it has its own private, large chunk of memory all to itself, starting from address 0. This simplifies programming and enhances security. A special hardware component, usually part of the CPU or nearby, called the Memory Management Unit, MMU, handles the complex task of translating these virtual addresses that programs use into the actual physical address in RAM where the data really resides.
Wow, MMU doing the translation. Complex stuff.
It is. And one challenge the OS constantly battles in memory management is fragmentation.
Fragmentation, like breaking things up.
Kind of. It means wasted memory space. Imagine you have lots of small, non-contiguous free blocks of RAM scattered between blocks that are currently in use. Even if the total free space is large, if there isn't one single contiguous block big enough to satisfy a new memory request, that request might fail, or the OS has to work harder to rearrange things.
Like having lots of empty parking spots, but they're all single spots scattered around and you need to park a big bus.
That's a perfect analogy. The OS uses various techniques to try and minimize this fragmentation and keep memory usage efficient. Understanding this whole memory management piece provides critical detail on how hardware, memory, and software, the OS, interact, which is crucial for grasping system performance and stability.
Okay, definitely complex, but makes sense. Now, it's not just the CPU and memory, right? Every time I click the mouse, type on the keyboard, save a file to my USB drive, or print something, how does the OS handle all these completely different devices talking to the computer in their own unique ways?
You're absolutely right. It's not just CPU and memory. Managing the vast and varied world of input-output devices is another huge job for the OS. That's I/O management. And it's remarkably complex precisely because of the sheer variety of devices out there. Mouse, keyboard, disk drives, printers, network cards, webcams, scanners, you name it.
So how does it talk to all of them? Does it know how every single printer works?
No, and thankfully it doesn't have to. The OS doesn't usually talk directly to the physical hardware of the device. Instead, it relies on two critical components acting as intermediaries. First, there's the device controller. That's the electronic interface, often a chip or set of chips on the motherboard or the device itself, that understands the device's specific signals. Second, and crucially, there are device drivers. These are software modules, little pieces of code that act as translators.
Drivers. I've definitely had to install drivers before.
We all have. The driver understands the specific commands needed to operate that particular device, like your specific printer model. The OS makes a generic request like, print this document. The driver then translates that generic request into the precise, low-level commands the device controller for your printer understands. And it also translates status information back from the device to the OS.
So the driver is the translator between the OS and the device hardware.
Exactly. This modular design is brilliant because it means hardware manufacturers can create new devices without requiring changes to the core operating system itself. They just provide a driver for Windows, macOS, or Linux, and the OS can then communicate with the new hardware.
That makes sense. Keeps the OS more manageable.
Definitely. Now, for certain types of devices, especially very fast ones like modern SSDs or high-speed network cards, constantly involving the CPU in every single byte transfer would be incredibly inefficient. It would bog the CPU down.
Yeah, moving huge files would take forever if the CPU did all the work.
Right. So for these high-volume data transfers, a sophisticated technique called direct memory access, DMA, is used. DMA allows certain hardware subsystems, like the disk controller, to transfer large blocks of data directly to or from the main memory, RAM, without needing the CPU's constant intervention for each piece of data.
The device talks straight to RAM.
Essentially, yes, managed by a special DMA controller. The CPU initiates the transfer, tells the disk controller, okay, move this block of data from the disk to this location in RAM, and then the CPU can go off and do other work. The DNAND controller manages the transfer and notifies the CPU with an interrupt only when the entire transfer is complete. This dramatically reduces the CPU's workload for I/O, boosting overall system performance significantly.
Okay, DMA for fast devices. Makes sense. How does the OS even know when a device needs attention? Like when I click the mouse or press a key?
Good question. It needs a way to detect input or know when a device has completed a task. The OS uses a mechanism called interrupts. Instead of the CPU constantly asking every device, do you have anything for me? Do you? How about now? Which is called polling. So very inefficient devices use interrupts.
Interrupts, like tapping the CPU on the shoulder.
That's a great way to put it. When a device needs the CPU's attention, maybe you click the mouse, a key was pressed, or a network packet arrived, the device sends an electrical signal, an interrupt signal, to the CPU. The CPU finishes the very instruction it's currently executing, then saves its current task's state, figures out which device sent the interrupts, and jumps to a special piece of code, an interrupt handler, often part of the device driver, to deal with that device's request.
Okay, so it handles the interruption.
Yes. Once the handler has done its job, like processing the mouse click, the CPU restores the state of the task it was working on before the interrupt and resumes right where it left off. This interrupt-driven approach allows the CPU to do other useful work until an event specifically requires its attention, making the whole system much, much more efficient than constant polling. This whole I/O management piece, again, reinforces those foundational IT concepts and really demonstrates the complex, elegant interplay between hardware and software, essential for describing the fundamentals of IT concepts.
Okay, one last piece of the OS puzzle, and it feels like a huge one these days. We live in a world constantly under the threat of cyber attacks, data breaches, ransomware. How does the operating system itself act as our first crucial line of defense? What's its role in security?
System security and protection is absolutely one of the OS's primary and most critical purposes. You're right, it is the digital gatekeeper in many ways. First off, it implements user authentication. That's your login screen, requiring a username and password, maybe a PIN, or biometrics like fingerprint or facial recognition. This ensures only authorized individuals can even access the system in the first place.
The first barrier.
Exactly. Once you're logged in, the OS enforces access control mechanisms. This determines what files, folders, applications, and system settings your specific user account is allowed to access or modify. Think about administrator versus standard user accounts on Windows or macOS. Admins can install software and change system settings. Standard users usually can't. This principle of least privilege is crucial in business settings to prevent users from accidentally or intentionally damaging the system or accessing sensitive data they shouldn't see.
Right, limiting permissions based on need.
Precisely. The OS also typically includes built-in firewalls. These monitor incoming and outgoing network traffic, acting like a security guard for your network connection, blocking unauthorized access attempts. And modern OSs provide robust support for encryption, both for data at rest, stored on your hard drive, and sometimes in transit over networks, making it unreadable without the proper key.
So authentication, access control, firewall, encryption. Lots of layers.
Yes. And knowing how to properly set up user accounts with strong, unique passwords, understanding the implications of administrative rights, and configuring these built-in security features is vital for protecting sensitive business data. But perhaps one of the most critical security functions related to the OS is managing updates.
Those update notifications. Why are they so important for security?
Because software, including the OS itself, inevitably has bugs and vulnerabilities discovered over time. Attackers actively look for these flaws to exploit them with malware, ransomware, or phishing attacks. Those OS updates you get, they aren't just for adding new emojis or features. Very often they contain critical security patches that close those known vulnerabilities, effectively shutting the door on potential attacks.
So ignoring updates leaves you vulnerable.
Massively vulnerable. Keeping your OS and your applications updated is one of the single most effective things you can do to protect yourself and your data. The practical takeaway here is immense for any business student and, frankly, for anyone using a computer. Understanding and actively using these OS-level security features and following best practices, strong passwords, keeping things updated, installing reputable antivirus software, being incredibly cautious about downloads and email attachments, enabling multi-factor authentication, MFA, wherever possible, it's all non-negotiable.
It's digital hygiene, basically.
It really is. This not only protects your own academic work and personal information, but also builds absolutely essential skills for protecting client data and confidential business information in your future career. It directly positions you for roles that require security awareness, maybe even leading into information security analysis down the line.
Okay, so we've gone deep into the OS, that invisible conductor running the whole show. Now let's shift gears a bit and talk about the stuff we create every single day, the files. Documents, spreadsheets, presentations, images. How important is it really to keep all that stuff organized? Isn't that just, for neat freaks or people who just have way too much time on their hands? I have to admit, my desktop is, well, let's just say it gets messy sometimes.
Oh, I think we've all been guilty of the messy desktop syndrome at some point.
Yeah.
But here's where it gets really, really interesting and why file management is far, far more than just tidiness. It's absolutely business critical. Seriously.
Business critical? Really? How so?
Think about it. In today's data-driven world, disorganized and rapidly growing data isn't just annoying. It can quickly compromise regulatory compliance, cripple operational efficiency, and lead to significant financial losses and missed opportunities. Consider the staggering statistic. Data worldwide is growing at something like a 19.7% compound annual rate. If you don't have a system to manage your piece of that explosion, you'll simply be buried under digital clutter.
19.7% a year. Wow.
It's fast.
It's incredibly fast. And surveys back up the impact. Gartner found that almost half, 47% of workers, struggle to find the information they need to do their jobs effectively. A big reason. Data silos, where information is just scattered across different folders, drives, maybe even different cloud accounts with no central organization.
Yeah, hunting for that one email attachment or that specific report version.
Exactly. And studies from IDC estimate that businesses lose around 21.3% of their overall productivity just due to document management challenges.
41%.
Yes, that translates to roughly 6 full workdays every single month, wasted restall, searching for files, dealing with version confusion, recreating lost work. It's a massive drain.
6 days a month. That's
Yeah.
huge. It's enormous. So good file management isn't just about having a tidy digital workspace. It directly boosts individual and team productivity, dramatically improves operational efficiency, ensures faster service delivery to clients or stakeholders, and ultimately increases business output. It saves companies very real time and very real money. It's a fundamental skill that literally underpins almost everything else you do with technology in a business context.
Okay, when you put it like that, losing 6 days a month, that's convincing. Can you give a specific example?
Sure, think of an emergency room again. If doctors and nurses can't instantly find a patient's critical records, maybe their allergy information, recent test results, medical history lives are literally at stake. The cost of disorganization is immediate and severe.
Right, life or death.
Now translate that to business. If you're in sales and you can't quickly locate that crucial signed contract before a deadline, or if you're in finance and you can't find the absolute latest verified sales report for forecasting, deals can be lost. Compliance regulations can be violated. Major strategic mistakes can be made. It directly impacts your ability to perform your job and succeed.
The stakes are high, even if not life or death.
Exactly. And this concept is absolutely foundational for what BCIS 1305 is all about. Applying essential and emerging business productivity information technology tools. How can you effectively use word processing, spreadsheets, databases if you can't find the files you need to work on? It directly fulfills that second learning outcome. Demonstrate proper file management techniques to manipulate electronic files and folders in local, network, and online environments. This isn't fluff, it's core competency. Hashtag TechTech 2.2 battle-tested file management techniques for business students.
Okay, I'm sold. It's critical. My own digital mess is frustrating, and thinking about it in a business context makes it even scarier. So where do we even start? If my files are currently scattered everywhere, desktop, downloads, folder, maybe some old USB drives, what's the very first step to getting this under control?
The very first step, and arguably the most important, is to embrace the single source of truth principle.
Single source of truth. Okay, what does that mean practically?
It means choosing one primary, central, logically organized place to store all your important digital documents and files. No more scattering. Whether that's a dedicated folder structure on your computer's main drive, maybe a shared network drive if you're in an office environment, or increasingly and ideally for flexibility, a cloud-based storage solution like Microsoft OneDrive, Google Drive, or Dropbox.
So pick one main hub, OneDrive, Google Drive, something like that.
Those are excellent choices, especially for students and professionals today. The goal is to eliminate those isolated data silos we talked about. Having one central place makes finding files infinitely easier, ensures consistency, and crucially, with cloud storage, allows you to access your files securely from multiple devices, your laptop, your phone, a library computer, wherever you are.
Access from anywhere is a big plus.
Huge. And for businesses, this often involves a concerted effort to digitize important paper records as well, getting them into that single, secure digital repository. Imagine you're managing a complex client project, say, planning a big event. If the budget spreadsheet is saved on your desktop, the vendor contracts are in your email attachments, and the latest client brief is on a shared folder someone else set up, you're practically guaranteed to run into problems.
Yeah, recipe for disaster.
Absolutely. A single, well-organized cloud location means all critical project details are instantly accessible, up to date, and available to everyone who needs them. That's the power of the single source of truth.
Okay, step one. Pick one central place, ideally cloud-based like OneDrive. Got it. But then, doesn't that central place just risk becoming one giant, disorganized digital dumping ground? How do I bring order to the chaos within my shiny new single source of truth?
That's the critical next step. You're right. Just piling everything into one folder doesn't solve the problem. That's where building your digital library comes in. And this relies on two key elements: creating a logical, hierarchical folder structure and using consistent descriptive naming conventions for your files.
Okay, folders and file names. Tell me more about the folders first. Hierarchy.
Hierarchy means creating folders within folders in a tiered system that makes logical sense for how you work or how your projects are organized. So after choosing your single storage location, like OneDrive, create a master folder, maybe called Work or Studies. Then within that, establish a logical system of subfolders. For your studies here at Tarleton, a good top level might be this semester, like fall 2025. Inside that, a folder for each course, BCIS 1305, ACCD 2301, etc.
Okay, semester course. Makes sense.
Then, inside each course folder, you create more specific subfolders, maybe assignments, lecture notes, readings, group project.
Okay. Drilling down into specifics.
Exactly.
Okay.
The key is to group related information together in a way that's intuitive for you or your team to navigate. For a property owner, it might be properties, apartment buildings, 123, main SAN, then subfolders like leases, maintenance records, tenant communication. This clear structure makes browsing for files much faster and reduces the reliance on just searching.
Right. I can just click through the logical path.
Precisely. Now, equally important, if not more so, are descriptive file names. Please, please, please avoid generic, meaningless names like document1.docx or finalreport.pdf or book1.xlsx. These tell you absolutely nothing.
Guilty as charged sometimes. Final report v2 really final.docx.
We've all done it. But a good file name should immediately summarize the content and context. Use key identifiers. For example, instead of sales report, try 2025 Q3 sales report regional west draft v2.xlsx.
Okay, that's much clearer. Date, topic, status.
Yes. Or for an assignment, BCIS 1305 assignment 3 database query your last name .dosquest. Include the course, assignment number, topic, maybe your name and submitting. Research from companies like M-Files actually found that a huge percentage, like 42%, of companies struggle significantly with poorly named or untagged documents. It's a major source of lost time.
So good names save time later.
Immense amounts of time. And the final piece ties it all together. Consistency is key. Once you establish your folder structure, semester course topic, and your naming convention, date, topic, version, or course assign, hashtag name, stick to it religiously.
Be consistent, even when I'm in a rush.
Especially when you're in a rush. Taking those extra 5 seconds to name and file something correctly now will save you minutes or even hours of searching later. Whether you're working solo on your coursework or collaborating with a team on a business project, consistency makes searching effortless, reduces errors, and ensures everyone can find what they need without confusion or delay. And this applies directly back to those BCIS 1305 outcomes, enabling you to effectively create business documents, Outcomes 326, and manage all your project files efficiently, whether for individual assignments or group work at Dr. Sam Pack College.
Okay, hierarchical folders, descriptive names, consistency. Got it. But manually creating all those folders, carefully typing out those long descriptive names for hundreds of files every week, that still sounds like kind of a nightmare. Feels like it could take up half my day just filing things. Is there a better, maybe smarter way to keep things organized without spending all that time?
That is a vital question for anyone who values their time, which should be everyone, especially productivity-minded professionals and students. You're right. Manual naming and filing, especially at scale, are incredibly time-consuming and, just as importantly, highly prone to human error. We get tired, we get rushed, we make typos, we put things in the wrong folder. And studies back this up. Some research suggests knowledge workers can spend up to 41% of their time on non-productive administrative tasks, and poor document management is a huge chunk of that.
41%. Wow, that's almost half the week on admin.
It's a shocking number. But the good news is, yes, there are smarter ways. The answer lies in leveraging technology itself to automate and optimize your workflow. You don't have to do it all by hand.
Automation. Okay, how?
Several ways. First, consider automated file naming and routing. There's specialized software out there, document management systems, or even sometimes built-in features in cloud storage that can help standardize your filing processes. For instance, some tools can automatically name documents based on predefined rules you set up, maybe based on the date created, the document type, identified by content, a client name pulled from the document, and then automatically route that file to the correct predetermined folder in your structure.
So the software names and files it for me.
In many cases, yes, or at least significantly assists. Some advanced systems can even perform optical character recognition, OCR, on scanned documents automatically, making those images text searchable, and then use the content to help classify and file them. It takes the human element and the potential for error largely out of the equation.
That sounds powerful. What else?
Think about document shortcuts or favorites. Instead of constantly clicking through 5 levels of folders to get to that one report template you use every day, or your resume or the current project's main folder, create shortcuts.
Like aliases on Mac or shortcuts on Windows.
Exactly. Pin them to your quick access in Windows File Explorer, or your favorites in macOS Finder, or even just put shortcuts on your, hopefully now tidier, desktop. This saves those repetitive browsing clicks and shaves seconds off accessing your most frequent files, seconds that add up fast.
Good point. Minimize the clicks.
Definitely. And for more complex business processes, think about file routing automation. Imagine a document needs to go through multiple steps for review or approval. Instead of manually emailing it from person to person, intelligent algorithms within workflow automation software can handle this. The system can examine the document's content or metadata, determine the correct workflow, and automatically route it to the right people in the right sequence for review, approval, signature, and final storage.
Taking the manual handoffs out of it.
Precisely. Remember that Xerox finding? Manual document processes lead to potentially thousands of wasted work hours annually for businesses just dealing with routing delays and errors. Automation can virtually eliminate these bottlenecks and inefficiencies. Think about a fast-paced consulting firm again. They might have automated workflows for proposal documents. When a draft is ready, clicking Submit for Review could automatically send it to the project manager, then the legal team, then finance for costing, all tracked by the system, ensuring it hits every necessary step before going to the client. Strict file naming combined with automated routing is essential. Any misfiled or delayed information could mean missing a critical deadline, losing a multi-million-dollar client, or jeopardizing a major project.
Okay, automation, shortcuts, routing. Makes sense for streamlining. But beyond just organization and efficiency, what about those heart-stopping moments, like accidentally deleting a crucial folder? Or maybe even worse, having 2 people working on the same document but creating different versions, and nobody knows which one is the right one. How do we protect against those kinds of digital disasters?
You've hit on 2 absolutely critical vulnerabilities: data loss and version control chaos. These can absolutely devastate productivity, destroy data integrity, and cause massive headaches. So protecting against data loss and discrepancies is fundamental. Let's break it down.
Please do. Version control first. That sounds messy.
It can be incredibly messy, especially when multiple people collaborate on a document or project. Versions inevitably proliferate. Without a clear system for version control, it's frighteningly easy for someone to waste hours working on an outdated file, only to have their changes overwritten or conflict with someone else's edits.
Yeah, merging changes later can be a nightmare.
It really can. You can try to manage this manually by adding tags like V1, V2, final to file names, but we all know how quickly that breaks down and becomes confusing.
My final V3? Yeah, I've seen that.
Exactly. A much better approach is to use automated versioning features built into many document management systems, or even some cloud storage platforms, like Google Docs History or SharePoint versioning. These systems automatically track changes, save previous versions, allow you to compare differences, and revert if needed. They provide a clear audit trail. One study by Nintex found that a third of employees struggle significantly with versioning issues, leading directly to duplicated work, confusion, and even serious compliance problems if the wrong version of a contract or report is used. Proper version control prevents this.
Okay, automated versioning is better. What about just losing the file altogether, deleting it, hard drive dying?
That's the second nightmare scenario,
Okay.
data loss. And the reality is it's not a matter of if data loss will happen, but when. Hardware fails unexpectedly, laptops get stolen, buildings suffer fires or floods, and sometimes we just accidentally delete the wrong thing or overwrite a critical file.
Scarily true.
And the cost can be immense. IBM estimates that the average cost of a data breach, which often involves data loss, is millions of dollars for companies. Even for an individual student, losing a term paper the night before it's due because your hard drive crashed. Devastating. So implementing a robust, regular file backup strategy is absolutely non-negotiable, period.
Backups. Okay, what are the options?
You have several layers you can use. You could use external hard drives. Regularly copy your important files to a separate physical drive. Good, but requires manual effort, and the drive could be lost, stolen, or damaged along with your computer. Better might be off-site servers or network-attached storage, AS, if you have access, physically separate from your main machine. But increasingly, the most reliable, convenient, and accessible solution, especially for individuals and many businesses, is cloud-based backup solutions.
Like using OneDrive, Google Drive, Dropbox for backups too.
Yes, many of their paid plans include robust backup and versioning features, or dedicated backup services like Backblaze or Carbonite. Cloud backups are particularly great because they're automated, usually running in the background. The data is stored securely off-site in data centers, and you can typically access your files from anywhere, even if your primary device is completely lost, stolen, or destroyed. It's your safety net.
Okay, cloud backup seems like the way to go for most people.
It's often the most practical and reliable. Finally, related to managing files long-term, businesses especially need a document retention strategy.
Retention, like how long to keep stuff?
Exactly. You can't just keep every file forever. Storage costs money. And keeping old, unnecessary data can actually increase your risk profile. More data to protect, more to sift through for legal discovery. Businesses need clear policies, often driven by legal or regulatory requirements, dictating how long specific types of files must be kept, e.g. financial records for 3 to 7 years, depending on regulations. And, just as importantly, how to securely dispose of sensitive data once it's no longer needed. This ensures compliance and helps manage storage costs and risk.
Right, getting rid of old stuff securely.
Yes. So version control, regular backups, ideally cloud, and a retention strategy. These techniques are absolutely crucial for demonstrating proper file management techniques, outcome 2, and for simply safeguarding your valuable academic work now and your critical business projects in the future. For your own term papers and group projects, seriously think about version control and make sure you have backups. It can literally save you from disaster right before a deadline. Hashtag 2.3, implementing robust security measures.
We touched on OS security earlier, but we hear about cyber attacks constantly these days. Ransomware, data breaches. It's relentless. How does good file management specifically help protect us from these ever-present threats, maybe going beyond just what the base OS does?
That's a critical connection to make. If your business suffers a significant data breach, the consequences can be catastrophic.
Yeah.
Huge financial losses from recovery costs and fines, irreversible damage to your reputation and customer trust, and potentially crippling regulatory penalties under laws like GDPR or IP. And the threat is very, very real. Remember that statistic. A gov.uk survey found that 31% of businesses experience at least one cyber attack attempt each week. It's constant.
Every week.
So, good file management isn't just about organization. It must integrate robust security measures directly into how you handle your digital assets. First, think about encryption and access control at the file and folder level. This goes beyond just your main OS login. You should implement strong encryption for sensitive data at rest, meaning while it's stored on your hard drive or cloud storage. Tools like BitLocker, Windows, or FileVault, macOS, encrypt your entire drive, but you can also encrypt specific files or folders. password protect highly sensitive folders or archives, and leverage those granular OS-level permissions we talked about, setting specific read-write-modify access for different users or groups on shared drives or folders to enforce the principle of least privilege. You want to control who can see or change what at every level possible.
Layering the security.
Exactly. Second, consider secure file sharing. How do you send sensitive documents to clients, partners, or even coworkers? Traditional methods like standard email are notoriously insecure. Emails can be intercepted, attachments can carry malware. It's just not suitable for truly confidential information.
So no sending contracts over regular email.
Ideally, no. Instead, businesses should utilize dedicated secure client portals or secure file sharing features offered by reputable cloud storage providers. These services provide encrypted channels for uploading and downloading files, often with audit trails, protecting the data in transit from eavesdropping or tampering. Some systems, like FileCenter's client portal mentioned in some sources, are specifically designed for this secure exchange.
Okay, use secure portals, not just email attachments.
Right. And third, don't forget about physical documents in a digital world. You need to digitize physical documents securely. Businesses still receive paper invoices, contracts, receipts, maybe copies of IDs. These need to be scanned and incorporated into your secure digital filing system promptly. Using scanning software, ideally with optical character recognition, OCR, is crucial here. OCR converts the scanned image into actual text, making the content of that scanned PDF fully searchable. This dramatically enhances your ability to retrieve that information later while still storing it securely within your encrypted and access-controlled digital system.
Making scans searchable is a big help.
Huge help for retrieval. So encryption, access control, secure sharing, secure digitization. These practices directly contribute back to Outcome 1, covering security and privacy fundamentals, and Outcome 2, focusing on proper file management and online environments. It also strongly underpins ethical conduct related to Outcome 8. Use web-based technologies to conduct ethical business research, because handling research data and business information securely and ethically is paramount. In essence, secure file management isn't an add-on. It's a proactive defense against significant business risks and, frankly, an ethical imperative in today's world.
Okay, going back to the OS internals for a bit, we talked about processes being isolated, running in their own spaces. That sounds great for stability. But if every program is a separate process, kind of walled off, how do they ever actually share information or work together? If I copy data from my spreadsheet and paste it into my word processor, how does that happen if they're supposedly separate?
That is a fantastic question, and it highlights a crucial concept, that isolation isn't absolute. What's really fascinating here is that contemporary operating systems rely heavily on mechanisms collectively known as inter-process communication, or IPC, precisely because processes do need to talk to each other.
IPC. Okay.
IPC encompasses all the ways the OS allows different independent processes to safely and efficiently share information, send signals, and coordinate their actions to achieve larger, more complex tasks. Like your copy-paste example, think of it again like different departments in a large company, maybe marketing, sales, and product development. They each have their own functions and data, but they constantly need to share information, customer leads, sales figures, product specs, and coordinate actions to launch a successful product. Without effective communication channels between them, the whole company would grind to a halt. IPC provides those channels for software processes.
So it's the communication lines between apps.
Essentially, yes. And a key aspect that goes hand in hand with IPC is synchronization. When multiple processes need to access or modify shared data or resources, like that clipboard you use for copy-paste, ensuring they do so in an orderly fashion is absolutely critical to prevent conflicts, race conditions, or corrupted data.
Synchronization, making sure they don't trip over each other.
Exactly. The OS provides synchronization tools. You might hear terms like semaphores, which act like traffic signals, controlling access to a limited number of resources, or mutexes, mutual exclusion locks, ensuring only one process can access a specific piece of shared data or critical section of code at any given time. These prevent chaos when processes share.
Okay, so how do they actually share the data? What are the methods?
The OS provides various approaches to IPC, each suited for different needs. One very common and often very fast method is shared memory. Here, the OS sets up a specific region of physical RAM that multiple processes are explicitly allowed to access directly. Once this shared region is established, processes can read and write data there at full memory speed. It's very efficient, but requires careful synchronization to avoid conflicts.
Shared memory, like a common bulletin board they can all read and write on.
Good analogy. Another fundamental approach, especially for network communication but also used locally, is sockets. A socket is essentially an endpoint for sending or receiving data. Processes can communicate by writing data to and reading data from sockets, whether they're on the same computer or across the internet. All web browsing, email, etc. relies heavily on sockets.
Sockets for networking. Makes sense.
There are others too, like pipes, simple, often unidirectional channels for data flow, common in command line interfaces. Message queues, where one process can leave a message for another to pick up later, good for asynchronous communication. And even just using shared files on the disk, though that's much slower.
Lots of different ways for them to talk.
Yes, the OS provides a toolkit. And the business relevance of understanding IPC, even conceptually, is quite profound. It's what allows complex enterprise applications, like your customer relationship management, CRM system, or your enterprise resource planning, ERP software, to be built in a modular way. Different components, running as separate processes, can handle different functions, like sales tracking, inventory management, financial reporting, but still communicate and share data seamlessly to provide an integrated view of the business.
So different parts of a big business app use IPC to work together.
Exactly. This modularity makes the software easier to develop, manage, and update. It can improve performance by enabling efficient data sharing, boost scalability by allowing different processes to run on different servers if needed, and even enhance fault tolerance. So understanding IPC conceptually builds on that first outcome, IT concepts, software, and really informs how those complex business applications actually manage to integrate business software applications, outcome 7, behind the scenes.
Okay, so processes talking via IPC is usually good. It allows collaboration. But what happens when things go wrong? What if processes can't talk effectively? Or worse, they get stuck, maybe waiting for each other in a way that creates a kind of digital gridlock? Can that happen?
That is a crucial question, and unfortunately, yes, it absolutely can happen. This brings us to the potentially nasty world of deadlocks.
Deadlock sounds bad.
It is bad. A deadlock occurs when 2 or more processes are blocked indefinitely, each waiting for a resource that is held by another process in the same group. They get stuck in a circular waiting pattern, and none of them can proceed.
A total standstill.
A complete standstill involving those processes. Imagine 2 trains approaching each other on a single track with no sidings. Neither can move forward because the other is blocking the track it needs. They are deadlocked.
Okay, the train analogy helps. How does this happen with software?
For a deadlock to occur in an OS, 4 specific conditions must hold true simultaneously. We don't need to memorize them all perhaps for BCIS 1305, but conceptually they involve things like resources being non-shareable, mutual exclusion, processes holding onto one resource while waiting for another, hold and wait, resources not being forcibly taken away, no preemption, and that circular chain of waiting, circular wait.
4 specific conditions have to line up just right.
Exactly. If even one of those conditions is prevented, deadlock cannot occur. But when they do all occur, the result for the user is often a frozen application, or sometimes even the entire computer becomes unresponsive. You lose unsafe work, and often the only solution is to forcibly terminate the processes or reboot the system.
The dreaded reboot.
We've all been there. Now, operating systems have various handling strategies for deadlocks. Some sophisticated systems try deadlock avoidance. The OS analyzes the resource allocation state and only grants a resource request if it can determine that doing so won't lead to a potentially unsafe state, one that could eventually lead to deadlock. This is complex, like the banker's algorithm you might hear about.
Trying to predict the future, almost.
In a way, yes. Other systems might use deadlock detection. Periodically, the OS runs an algorithm to check if a deadlock cycle currently exists among the waiting processes. If it detects one, it then needs a recovery strategy which might involve terminating one or more of the deadlock processes, losing their work, or preempting resources, which is often difficult.
Detecting it after it happens and trying to clean up.
Right. And then there's the most common approach in many general-purpose OSs like Windows, macOS, and Linux. Deadlock ignorance, sometimes jokingly called the ostrich algorithm.
Ignorance. They just ignore it.
Essentially, yes. The rationale is that true deadlocks are relatively rare in well-designed systems, and the overhead of constantly running avoidance or detection algorithms might slow down the system more than the occasional deadlock causes problems. So the OS provides no special mechanism. If a deadlock happens, the system or application freezes, and the user is expected to notice and manually intervene, usually by killing the process or rebooting.
So Windows just hopes it doesn't happen often.
Largely, yes, for application-level deadlocks. Now, it's also important to quickly distinguish deadlock from a related condition called starvation.
Starvation? Is that different?
Yes, they are not the same, though both involve processes not making progress. Starvation, or indefinite blocking, occurs when a process is technically able to run, it's in the ready state, but is constantly overlooked by the scheduler. Maybe it has a very low priority, and there's always a higher priority process ready to run, so it never gets its turn on the CPU or waits forever for a resource. It's being starved of CPU time or resources, but it's not necessarily part of a circular wait like in deadlock.
So it's just stuck at the back of the line forever.
Potentially, yes. Starvation can often be prevented by techniques like aging, where the OS gradually increases the priority of processes that have been waiting for a long time, eventually ensuring they get a turn.
Okay, deadlock is a circular wait standstill. Starvation is being perpetually overlooked.
Good summary. And the business relevance here. Understanding these concepts of resource contention, deadlocks, and starvation, even at a high level, is surprisingly vital for business students. Think about managing resources in any project. If two critical teams absolutely need the same piece of specialized, non-shareable equipment at the exact same time, and there's no planned or scheduling mechanism, they could effectively deadlock each other, bringing progress on both their tasks to a halt. Project delays, missed deadlines, cost overruns.
A real-world deadlock analogy.
Exactly. Good project management, like good OS resource management, using techniques analogous to deadlock prevention or avoidance, involves planning, scheduling, and prioritizing resource allocation to ensure that projects, processes continue to move forward efficiently and don't get stuck waiting for each other unnecessarily. It's about understanding dependencies and managing contention.
Okay, so we've journeyed pretty deep into the technical workings of operating systems processes, memory, I/O, IPC, even deadlocks, and then we covered the crucial practices of file management and security. But let's bring it all home. What does this really mean for a student right here, right now, studying BCIS 1305 at Tarleton State University? How does diving this deep into OS and file concepts actually connect to our future career goals after we graduate from the Dr. Ciampa College of Business?
This is truly the crux of it, isn't it? Connecting the foundational knowledge to practical application and career readiness. That's the core of what we aim for here. All these concepts we've discussed, understanding how the OS manages resources, how files should be organized and secured, they directly prepare you, they empower you to effectively apply those essential business productivity software tools that BCIS 1305 focuses on.
The tools like Word, Excel, Access, PowerPoint.
Exactly. When you grasp concepts like memory management and process scheduling, you gain a much deeper understanding of why your word processing software, outcome 3, runs smoothly sometimes and sluggishly other times. You understand how complex spreadsheet calculations, outcome 4, are actually being handled by the CPU and memory. You appreciate what ensures your database queries and access, outcome 6, execute efficiently without corrupting data. It's about building that robust foundational base that supports everything else you do with business software. You learn not just the how of using the tools, but a bit of the why behind how they work.
So it's not just clicking buttons, it's understanding what's happening underneath.
Precisely. It helps you troubleshoot better, use the tools more efficiently, and even anticipate potential problems. It enhances your ability to leverage presentation graphics effectively. Outcome 5. Engage meaningfully in data analytics using techniques like goal-seeking and what-if analysis, outcome 9, and effectively, securely, and ethically utilize the internet for business research, outcome 8. When you can confidently describe the fundamentals of information technology concepts, hardware, software, security, and privacy, outcome 1, and demonstrate proper file management techniques, outcome 2, you're not just learning abstract theory, you're building a rock-solid base for practical, real-world application.
Okay, so it makes us better users of the core business software. What about jobs? How does this translate to the job market, say, right here in the DFW area?
Great question. We've looked into this, and our research consistently shows that employers right here in the Dallas-Fort Worth Metroplex, we're talking major players like AT&T, Dell Technologies, Bank of America, consulting firms like Deloitte, American Airlines, and countless others are actively seeking graduates with a strong, practical foundation in these exact areas.
They want these OS and file management skills, really.
They want the competencies that these skills enable. Let's look at some direct applications to specific job roles that Tarleton graduates might pursue. Think about an IT support specialist or help desk technician. These roles absolutely require a profound understanding of operating systems, Windows, macOS, maybe Linux, troubleshooting techniques, user account management, and efficient file management to diagnose and resolve user issues effectively.
Yeah, help desk needs to know the OS inside out.
Definitely. Or a network administrator. Knowledge of how the OS manages hardware resources, handles interprocess communication for network services, implements security policies, and manages file permissions on servers is absolutely critical for maintaining network integrity and reliable server operations.
Okay, direct IT roles make sense. What about less technical business roles?
Even there, the skills are surprisingly relevant. Consider a business analyst or a data analyst. While their primary focus isn't the OS itself, their ability to work efficiently hinges on meticulous file organization for managing complex data sets, ensuring data integrity, tracking document versions, and collaborating effectively with others. Poor file management can completely derail analysis.
Right, managing all that data requires organization.
Immense organization, even roles like software developer. While they focus on coding, a strong grasp of OS concepts like process management, memory allocation, and IPC is fundamental for writing efficient, stable, and secure code that performs well. And certainly an information security analyst. Understanding OS-level security features, vulnerabilities, access controls, encryption, and best practices for file protection and secure data handling is a direct pathway into this incredibly fast-growing and critical field.
So the skills are applicable across a wide range of roles.
Absolutely.
Yep.
Now, while your BCIS 1305 curriculum and other coursework here provide an excellent foundation, it's also important to recognize skills gaps and opportunities that can make you even more competitive in the DFW job market. Employers are increasingly looking for skills that build upon this OS and file management foundation. Things like certifications or demonstrable skills in cloud platforms like Amazon Web Services, AWS, or Microsoft Azure. Proficiency in specific data analysis tools like Power BI, Tableau, or even advanced Excel. Familiarity with common programming languages used in business automation and data analysis like Python or maybe Java.
Sure.
And definitely further knowledge or certifications in cybersecurity like CompTIA Security Plus.
So using the foundation to build more specialized skills.
Yeah. Exactly. The practical takeaway for you as a student is crystal clear. Mastering OS fundamentals and file management best practices doesn't just make your current coursework in BCIS 1305 easier. It directly makes you more efficient and capable in using all the tools required for Outcome 3 through 9 word processing, spreadsheets, databases, presentations, web research, data analysis. More importantly, demonstrating these skills shows potential employers that you are adaptable, tech-fluent, detail-oriented, and professional. These are qualities that open doors, not just to entry-level positions, but to more specialized roles and long-term career growth in any modern business environment that relies on technology. And today, that's pretty much every environment. #tag outro.
Wow, okay. We've covered a lot of ground today. We've journeyed from that invisible conductor of your computer, the operating system, navigating through the really intricate dance of processes and memory management, all the way to the practical day-to-day skills of mastering your digital files for peak business efficiency and, crucially, robust security. We saw how a deep understanding of these fundamentals isn't just, academic stuff for IT majors. It's truly a practical, career-boosting superpower that impacts everything we do with technology, from everyday productivity right up to advanced cybersecurity awareness.
Absolutely. And remember that feeling we started with, that sense of mystery when your computer seemed to have a mind of its own, or that intense frustration when a crucial file just vanished into the digital ether. By demystifying how operating systems actually work, pulling back that curtain, and by giving you some battle-tested practical file management strategies, we really hope you now feel more empowered, more in control of your digital world, ready to use technology as the powerful tool it can be, rather than seeing it as a perplexing challenge.
Definitely feeling more empowered. And if you enjoyed this deep dive and found it valuable, please take just a moment to hit that like button, subscribe if you haven't already, and maybe share it with a classmate or colleague who might benefit. Your support genuinely helps us continue to bring you these essential insights for your studies and your future career growth. And don't forget, the episode description below has links to additional resources, maybe articles or tutorials, to help you keep your learning journey going on these topics.
Right. And as you step away from this discussion and think about the vast digital landscape of modern business, consider this. How will your improved understanding of operating systems and your commitment to disciplined file management not only make your current coursework and projects easier, but also strategically position you to tackle the inevitable future technological challenges and seize the opportunities that come with them? The future of business isn't just about what you know. It's really about how effectively you apply technology to make things happen. Thanks for listening.